Hey there fellow coders, welcome back to another episode on CodeMaster Quest. In today's episode, we are dealing with a captivating physics-based puzzle in a 2D grid. So without any further delay, let's find out the problem statement on LeetCode. Where will the ball fall? You have a 2D grid of size m rows and n column representing a box, and you have n balls. And the box is open and on the top and bottom sides. So each cell in the box has a diagonal board spanning two corners of the cell that can redirect a ball to the right or to the left. We have two kind of cell in this grid, right? A board that redirects the ball to the right spans the top left corner to the bottom right corner and is represented in the grid as 1. And a board that redirects the ball to the left span the top right corner to the bottom left corner and is represented in the grid as -1. And we drop one ball at the top of each column of the box, and each ball can get stuck in the box or fall out of the bottom. A ball gets stuck if it hits a V-shaped pattern between two boards, or if a board redirects the ball into either wall of the box. And at the end, we should return an array answer of size n, where answer I is the column that the ball fall out of at the bottom after dropping the ball from the column at index I, or -1 if the ball gets stuck in the box. So if we look at the example number 1, if we receive a grid like this one, and if we drop one ball from each column, for B1 we will get stuck in the box because we have a V-shaped pattern here. Same thing for B4. The B4 will be stuck here in this V-shaped pattern, and for B2 and B3 we will get stuck in this V-shaped pattern, right? But for B0 at the end of the move, we will it will fall out from column number 1, right? So for this example, we should return this array. For B0, it will drop out from column number 1, so we should return -1, actually 1 for B0. But for other for other balls, since the ball will get stuck in the grid, we should return -1. So this would be the return value for other balls. Now to solve this question, let's get back to the Visual Studio Code and try to solve it. To solve this question, let me mention a few number of observations. Let's come back to the browser and check this example. We have two kind of cells in this grid, right? Left diagonal and right diagonal cells. A right diagonal cell would be something like this, and we are representing these cells in the grid with 1. And left diagonal cell would be something like this one, row 0 and column 4, and we are representing this kind of cell in the grid with -1. To solve this question, we need to have two observations. What is the position of the ball after one move in this grid, and what is the condition to get stuck in a V-shaped pattern? So let's get started with B1. If we started with B1 from row 0 and column 1, since we are facing with a right diagonal cell, we would move to the right. And for B4, we would move to the left because we are facing with a left diagonal cell. And since we are representing this kind of cell with 1 and this kind of cell with -1, to calculate the position of the ball after one move, it's good enough to calculate the column number by increasing the value of the previous column with the value of this cell in the grid, right? And to find out what is the condition to get stuck in a V-shaped pattern, if you look at here for B3, if we start from row 0 and column 3, we would move to the left because we face with the left diagonal cell, and the value of this cell in the grid is not equal to the previous one, right? So the condition to get stuck inside a V-shaped pattern is that the next position of the ball in the grid have a value different from what we have in the previous position. So this is the condition to get stuck in the V-shaped pattern. Now that we have this observation, let's come back to the Visual Studio Code and try to solve this problem. Same as always, and as a first step, let's define the function signature here. So let's say fun find ball, then input for this function, which is a grid, an array of integer, a 2D array of integer actually. And at the end we are going to return an array of integer. And to store the return value for this function, let me define a variable here, result, array of integer, and it's empty by default. And at the end we are going to return this result, right? So in the body we need to define the movement logic. And for this purpose, to implement the movement logic, I want to define a helper function that will receive the coordination of a ball and calculate the movement for a ball. So let me say find ball drop column. It's going to receive the coordination of a ball in this grid. So let's call row column integer, and for sure we need to have the grid as well. So, and at the end of this function, we are going to return the position of the ball, right? So to find out whether this ball is already dropped out from the bottom of the grid, let me say if row is equal to grid dot count, then this means that we fall out from the bottom of the grid, and we need to return column as a result. Now we need to find out the column after one move, and based on our observation we can say next column is going to be column plus grid for row and column, right? So this would be the position of the ball after one move regarding the column. Now we need to check whether we get out of the grid system from the valves or we stuck in a V-shaped pattern. So for this purpose, if next call is less than 0 or next call is greater than grid 0.count -1, this means that we are out of the grid from the right hand side, or grid for row and column is not equal to grid for row and next column, right, based on our observation. In this case, we should return -1 based on the question description. Otherwise, we should find out with a recursive call to the same function, right? So let's say return find ball drop column for row +1 and next column, and we should pass the grid as well. Now let's come back to the movement logic for I in 0 to let's say grid 0.count, let's say result that append find drop ball column, or find ball drop column actually, for row number 0, column number I, and grid is grid, right? And this should be the correct implementation, but to make sure about it, let's come back to the browser, find out the input here. Where's the input? Yeah, there we go, here. And now let's come back to the Visual Studio Code, paste it just right here. Maybe I can copy this part. Let's say let grid equal to this one, and print find ball for this grid, right? It should be a correct call to our function. Okay, there we go. Let's see whether it's working. So if problem, let's say we expect to receive 1, -1, -1, -1, and -1. So it seems we have a correct solution. As the last job, let's submit our solution to LeetCode. Change to the browser and paste our code just right here and hit the submit button. There we go. Here's the solution for this question. Thank you, everyone.